Okay, inequality. It's used to compare values when they are not equal. In other words, when one thing is more than the other or less than the other, things like that. Okay. And we're going to do that with symbols, right? Math is all about symbols. So these are the inequality symbols. Hopefully you're comfortable with all of them, or you've seen all of them. I know that you've probably seen at least two of these. So inequality symbols. All right. So the first two I know you're familiar with. So the first one looks like this. Does that one look familiar? You've seen it before? That one is it's called the is greater than symbol. Is greater than. Like 7 is greater than 2. Okay? So if I'm doing an example, I can do that. Let's do 7 is greater than 2. Remember the way we all probably learned this? The crocodile eats the bigger number. The open portion is to the bigger number. Okay. I'm seeing a lot of shaking of heads. Yes, good. So we've got that one. We also have its partner in crime. Anybody know what we call this one? Less than, or is less than, to be exact. But we all say less than. I do too. But a very, very smart English teacher who actually knew her math facts as well suggested that I explain to you guys that it is less than and is greater than, because it completes a math sentence. And if we just say less than, it wouldn't be a math sentence. Good point. Okay. So if I'm using the same number 7 and 2, how could I use this one? 2 and then 7. 2 is less than 7. All right. I think we're going to do well in this. So those are the two most common ones. But maybe you've been introduced to the next two. I'm hoping you have. Ever seen this one? It's kind of like the is greater than, but it has this little bar underneath. Are you guys familiar with that one? Okay. It's practically the same as the is greater than. In fact, it starts off the same way. Is greater than. But there's more. Or equal to. That's the part that's extra. Just think of it as it's extra. And you know what that means, basically? I could have this. I could have 7 is greater than or equal to 2. I could have that. And I can also have 7 is greater than or equal to 7. That would also work. Both of those are true. 7 is bigger than 2, right? But isn't 7 equal to 7? So the number that we're comparing for itself is part of the answer. We couldn't say that with this one. I couldn't say 7 is greater than 7. That's not true. But 7 is greater than or equal to 7. The equal to part is the part that works. Does that make sense? Okay. It's a little change. It's a little refinement, but it's going to make a big difference. Okay, the last one is less than or equal to. Less than or equal to. And to make Miss North happy, we're going to say is less than or equal to. Bless you. Okay. And so we can use the example we used before here. We can say 2 is less than or equal to 7. That's true. And 2 is less than or equal to 2. That's also true. Okay. Now we're going to continue our table. Can you think of words that tell us when we're using one or the other? I'll give you one for greater than or equal to. Have you ever said more than? If you've ever said more than, something is more than another thing you're comparing using this symbol. Okay? Have you ever said fewer than? There are fewer students in my first period than in my fourth period. That's this. You actually probably know more ways of saying greater than or equal to and less than or equal to than these. I'll give you an example. Greater than or equal to. Have you ever used it? You probably use it every day, actually. Have you ever said at least? The distance to the mall is at least 5 miles. That's greater than or equal to. If you ever said at least, it's greater than or equal to, because in the sentence I just said, it's 5 miles or more, right? Isn't that what that means? If you ever said at most, if you ever said at most, then you've used less than or equal to. Yeah. The number of students that can fit in the bus is at most 52. Okay, that means it has to be 52 or less. Another one for greater than or equal to is no less than. If you've ever used no less than, that's greater than or equal to. And no more than would be for less than or equal to. No more than. So these things are used in everyday situations. Let me just finish up my table there. So now, we typically use these to compare things. And we're going to find solutions to inequalities. So we're going to state 3 or more solutions to the inequality. What is she showing over there? A novela? No study sync. Got it. Okay. Alrighty. So here's what I'm going to do. We'll give you an inequality. Let's say t is greater than 8. And we're going to identify at least 3 numbers that would work. So what numbers can I replace with t that would make this true? Yes. 9. That's the most obvious one. Popped in my head right away. 9 is greater than 8. But the thing about inequalities is there's an infinite number of answers. So could I say 10? 10.78, would that work? Could be a decimal. Anything else? 200,000. Would that work? Basically, anything bigger than 8 would be a true answer. Okay. Let's try this one, number 2. X is greater than or equal to negative 8. All right. Let's see, what would work here? Yes. Ooh. Okay, I like that. Start off. That's the key difference between these two. The number itself that we're comparing is part of the answer. So negative 8 would be true. 8 is greater than or equal to negative 8. And then, pick your favorite positive or negative numbers as long as they're bigger than negative 8. 0, would 0 work? That's bigger than negative 8. What else? Decimal number. Ooh. Why not? We can even go 10 and 7/9. Could be decimal. A fraction rather. Okay. All right. One more. Just because you guys are on it here. M, this is number 3, by the way, is less than or equal to negative 4. You got to be careful with the negatives, though. Remember how the negative side of the number line works. But it's got that equal to part, so which one can I include for sure? If it has the equal to part. Negative 4. Negative 4 absolutely would be part of the answer because of the equal to part. And all I want are numbers less than negative 4. What would work? Think of the number line, how it's looking for negatives. What's negative what? Negative 92, yeah. Let's do a decimal. Negative, what? 6 point, negative 6.70 what? 72? Okay, and let's do negative 11 and 5 over 13. How's that? All of these would work. Here's the thing. I could sit and write numbers till, well, I could never stop writing numbers that would work, right? So rather than do that, if we want to show the solutions, all the possible solutions to an inequality like this, I usually don't write a list of numbers. What I usually do is make a graph on a number line. So have you guys ever made graphs on the number lines for these, for inequalities? Let's start. That's our next task. We're going to graph inequalities. Hi, Mr. Contreras, cut off that's a 13 there if you missed it. Okay, we're going to graph inequalities, guys. Grafiar, that's not how you say graph, by the way. Gráficas. Graph inequalities on a number line, because you could do it on a coordinate plane as well, but we won't do that this time. Okay, so we're going to do 4 examples just to get the idea. So let's say you have an inequality that you want to graph, or you want to show all the possible solutions. So let's say I have this inequality. N is greater than -1. Go ahead and write that down. N is greater than -1. I want to show all the possible answers that would work there. So I got to make a number line. So let's start with that. So now I got to make a number line. And there's one very important number I have to have, or else this number line won't make sense. And that's this number here, -1. So I call that the star of the show. And then I'll just put a few numbers on either side of that number. So thinking of the number line, I would have 0, 1, and maybe 2 on that side. On the other side, I would have -2, -3, -4. So there's my number line. And I want to show all the possible answers. Okay? So here's -1. Here's my number that I'm interested in. Would the number 0 or the number -2, which one would work? Which one is bigger than -1? -2 or 0? Which number is bigger? 0. Numbers to the right are always bigger than numbers to the left on a number line. Okay, so I would put a little dot there. How about 1/2? Would 1/2 be bigger? How about 1/4? Would 1/4 be bigger? How about the number 1? So I could just do this forever, but I don't want to do that. So what we usually do is we just usually make a nice solid one. And guess what we do to show that it goes on forever in that direction? Put a little arrow. In math, we like to put arrows to say it just keeps on going. Now, can I include -1 as my answer? Is -1, would -1, is it greater than -1? Would that work? It wouldn't work. So I got to show that -1 itself is not an answer, but everything up to -1 is an answer. So we're going to make what's called an open point. So what I want you to do at -1 is draw a nice big circle, like that. This is called an open point. So an open point means that's not part of the answer, but everything either before or after, depending on what kind of a graph, number line graph we have. So this is showing all the possible answers that will ever exist for this particular inequality. Okay? Any questions? Raise your hand if you've done these before. Has anyone done these before? Okay. All right. Well, they're not that hard, hopefully you'll see. And especially if you're a visual person, I'm a visual person, it just makes sense with a few of the tricks I'm going to show you. Let's try another one. Let's try greater than or equal to. N is greater than or equal to -1. Okay, so we're going to make a number line once again. Let's make the same number line, -1, kind of in the middle, and a few of the numbers that belong here. There they are. So there's our number line. And this time, it's all the numbers greater than -1 again. So it's all those same numbers. So I'm just going to make a number line going this way on to infinity, like that. Now, is the number -1 part of the answer? In this case, remember, can I say -1 is greater than or equal to -1? Is that true? That -1 is greater than or equal to? It is actually, right? So the number -1 is part of the answer. So I don't make an open point there. I make a nice big point like that, a big, nice, chunky point like that. That's called a closed point. So that's a closed point. And that's telling me -1 and anything bigger than -1. Okay? Now, let's see if you're a visual learner. Look at my inequality symbols and look at the side that I shaded. Do you see that? Isn't it saying shade to the right? Isn't this one saying shade to the right? Let's see if I do the less than ones next, if it's going to tell me to shade to the left. Let's see if that works. So let's try that. So here we go. Let's try the next one. K is less than -1. Keep it simple. So once again, -1 is in the middle. Okay. And this time we want all the numbers less than. K has to be less than. Anything that would work would be less than. So do we want numbers to the right over here or to the left? To the left. And it's everything to the left. So everything this direction would be a solution. So I would shade that. Now, would I make it an open point, do you think, or a closed point? What's it going to be? Open. That's telling me that -1 is not part of the answer. -1 is not part of the answer, so it's open there. But everything less than that. Okay. So take a look. Is it telling me to shade the inequality symbol? Is it telling me to shade to the left? Is it telling me shade this way? You see how it's pointing that way? It said shade this way. And that's what I did. Okay, let's do an equal to one. K is greater than or equal to -1. Okay. Okay. So which way are we going to shade? Left or right? This time it's to the right. We want everything bigger than -1 again. Okay. Do we want an open or a closed point? Do we want the open dot or the closed dot? We got the equal to part. We want the closed dot. Basically, anytime we've got that bar underneath telling us it's equal to at that location, you shade it in. Now, do you see how it's telling me to shade that way? This is pointing this way, so I shade that way. Okay, so part of what we're going to do on today's assignment is they're going to give you one of these, and you have to make the correct number line graph. Okay? So I ran out of room here. I'm going to go on to the next page. So if you're ready, we're going to practice a little bit of graphing this way. Okay? You guys ready? All right, let's do it. Here we go. Page 31. Okay, and what we're going to do is we're going to graph the inequality. Okay, write this one down. Number one, numero uno. M is greater than or equal to 5. We're going to graph this. We want all possible solutions. So which number do we absolutely, positively, without a doubt, have to have on our number line? 5. Put it right in the middle. Then pick a few numbers on each side. Maybe 6, 7, and 8. 4, 3, and 2. Okay, now, I usually start at that number. Do I make an open or a closed point? Closed. I got an equal to part. If I got that little equal to bar, the point there has to be closed. Now, do we want to shade to the left or to the right? To the right. Yeah. We want all numbers bigger than 5. So they would go this way. And we're done. Okay, this is going to tell me all numbers bigger than 5. How are we doing? Any questions? Okay. The only thing that would make it a little tricky is the following. Number 2. Let's say I have 7 is greater than X. So the star of the show is 7. We know that. I gotta have 7 in here. And maybe 8, 9, and 10. Over here I'll do 6, 5, and 4. Now, what's different about this inequality that might make it confusing? What do you notice that's different with this one that we haven't had in any of the inequalities we've written? The numbers first. Do you see that? Usually we've had the variable on the left. This one has the number that we're comparing on first on the left. And it will make a difference. The only reason this visual thing was working for us, that if it's pointing to the right, you shade to the right. If it's pointing to the left, you shade to the left, was the variable came first. But we can fix this. If ever I see this, I'm going to do the following. I'm going to do a flip. Because every inequality can be written in one of two ways. I can say 7 is greater than X, or if I flip it, what's another way of writing this? X is not greater than, it's going to be less than 7. Do you see what I did? I just turned it over. I flipped it around. Okay? So this is going to be what I'm going to look at for my graphing. This is good for graphing now, because it tells me a couple of things. First of all, at 7, open or closed? What do we got there? Open point. We do not have the equal to part, so it's open. Now, do I shade to the left or to the right? Look at this one. This one is pointing to which direction? The one on the bottom. You see how it's pointing this way? It's saying x is less than 7. Which numbers are less than 7? These numbers. Okay, so if they flip it around on you and give you the number first and the variable on the right, just turn it over. Okay, let's try one more like that. Number 3, negative 12 okay, is greater than or equal to m. Okay, so let's make our number line. What number do I absolutely positively have to have? Negative 12. And then so I want negative 11, negative 10, negative 9. Those go there. Those are all bigger. Negative 13, negative 14, negative 15. Those are all less than that. Okay, so I better do something on this one. The number's coming first. I don't want that. Do a flip. Flip it around. What's it going to look like? M's going to come first. M is less than or equal to negative 12. You just turn it around. Okay, so this is what I'm going to use to graph. Okay, now, do I want, at negative 12, do I want an open or a closed point? What do I want at negative 12? Closed. It's got the equal to part. This time it's going to be closed. Do I want to shade to the left or to the right? Look which way it's pointing. To the left. We want everything over here on this side. The answer would be this. Negative 12 and anything smaller than negative 12. Okay? So the other thing we're going to do is, instead of giving you the inequality, you make the graph. What if you get the graph and they want you to write the inequality? Okay, so we're going to write the inequality from the graph. Okay, so we're just working in reverse. So let's say I give you something like this. Let's do 0, 1, 2, 3, negative 1, negative 2, negative 3. And I'll do this point and everything this way. And from there, I'm looking for the actual inequality. Let's use x. X is, I'm shading to the right. If I'm shading to the right, will it be a greater than or a less than? If I'm shading on the right side, it'll be greater than, because all the numbers are getting bigger. Do I need to put the bar underneath for equal to? Look here. Yes. You see how it's a closed point? You want the bar there. and then I want 0. So that would be my answer. X is greater than or equal to 0. Okay? Any questions? Okay. We'll just do 2 more and then we'll be done. Okay, let's do -20, -19, -18. So there's my number line. I will put an open point, and then everything to the left is an answer. Okay? So if we see this graph, what would we write? X is greater than or less than? What's it going to be? Less than. If it's shading to the left, it's less than. Do we want, it's an open point. Do we want to put the bar underneath? Nope. So X is less than what number? -20. There we go. Okay. Last one. Number 3. Okay. Let's do 1/2. We'll do 1 there, 0 there. Not evenly spaced, but just so we get the idea. Okay. This time I'm going to do this. Okay. Try this one. X is what? Greater than or less than? Greater than, and 1/2. Do we need the equal to part? No, it's an open point, so we don't need the equal to part. Okay. All right, ladies and gents. So the assignment on Delta Math is going to be this. For today, they're going to give you inequalities and you make the graphs, or they give you the graphs and you write the inequalities. Okay, so open up your Chromebooks. Let's go to Delta Math. I'm sorry, not Delta Math. Did I say Delta Math? Yeah. IXL. It's on IXL. Okay, is anyone still writing any of this down? No.